Good afternoon, everyone, and on behalf of the Friends of the Village Library of Cooperstown, welcome to the third of the Sunday Speaker Series for 2020-2021 with Dr. Antoinette Kuzminski and her presentation on emerging contaminants in Lake Otsego and the Susquehanna River. My name is Leanne Hirabayashi, and I'll be co-moderating this session with Maureen Murray, along with technical assistance from Martha Membrino. Thank you all for joining us. Let me go over a few items related to logistics and format for this session. There will be a couple brief messages from the host and sponsor, after which I'll introduce our speaker who will make her presentation. Then we'll have a question and answer session, which will be handled by my co-moderator, Maureen Murray. For attendees, and it looks like we're up to about 20 so far, at the bottom of your Zoom window, you will see several icons in a bar similar to what I'm showing here. Please note that chat is disabled and we are not using the raise hand feature, just that Q&A tool. If you have a question, you click on that Q&A tool, and Maureen will be monitoring that and asking questions on your behalf. So just click on that tool and send in your questions. Please note that we may not be able to get to all questions, and we appreciate your understanding on that. Go ahead and just submit your questions, as I said, throughout this presentation. Finally, the programs in the Sunday Speaker Series is being recorded, and a link to each recording will be made available on the Friends of the Village Library webpage. The Friends of the Village Library works closely with the library to sponsor educational and entertaining programs for the Cooperstown community. The annual Sunday Speaker Series is one way the group fulfills its mission by hosting a slate of monthly programs, usually scheduled from October through May. Each year, the series features a diverse group of speakers on topics that have included discussions with local artists, local history and geology, climate change, healthcare, authors, journalists on the issues of the day. As I said before, today's program is that third in the 2021 Sunday Speaker Series. The League of Women Voters of the Cooperstown area is grateful for this opportunity to sponsor the Friends of the Village Library Speaker Series with its goal of providing educational programming to the community. Serving the village of Cooperstown, the towns of Otsego, Middlefield, Springfield, and Hartwick, and surrounding towns in northern Otsego County, we are a nonpartisan political organization. The League of Women Voters encourages the informed and active participation of citizens in government and works to increase understanding of major public policy through education and advocacy. To find out more about the League, please go to our website at lwvcooperstownarea.org. And now let's move on to today's program. Antoinette Kuzminski served as attending physician and associate professor of medicine at Bassett Hospital from 1976 to 2016, a resident of the Cooperstown area for 4+ decades. She has volunteered with a number of local nonprofit organizations. As I said earlier, Antoinette's topic today is emerging contaminants in Lake Otsego and the Susquehanna River. The term emerging contaminants refers to a group of thousands of previously unrecognized substances, almost all man-made, that are now being found in small amounts in fresh waters worldwide. As a general internist, Dr. Kuzminski became aware in the 1990s of the concept of endocrine disruption due to emerging contaminants and their impact on human health. She joined with SUNY Oneonta's Biological Field Station and the U.S. Geological Survey to study the presence of emerging contaminants in Lake Otsego and the Susquehanna River. Her talk will review these recent investigations and in particular, the potential for endocrine disruption in aquatic and human life. So now I'm going to end my slideshow and stop my share. And Jeanette, if you haven't unmuted yourself, please do so and take it away.
Okay, so I'm just going to, hi everybody. I'm just going to outline my talk and tell you how sort of the rough outline. First, I'm going to describe what are the emerging contaminants, how I got interested in them and in endocrine disruption. I'm going to present the results of the study that we did in 2018. As a crowd pleaser, just to tell you that there were very, very low levels of 3 contaminants in Otsego Lake, which we'll discuss. The river didn't look that great. I'm going to talk about the meaning of these contaminants and some changing ways of looking at toxicology, changing paradigms that make it very difficult to decide whether these things are worrisome or not. Almost certainly they are. And then I'm going to talk about what's next. And finally, there's a bibliography. So what are the emerging contaminants? There's no legal definition for that term. The word emerging has been used because these are basically new, or at least they're newly recognized. They're newly recognized sometimes because our assays have become increasingly sensitive and our methods of detection are so much better than they used to be that these are new to us, although they may have been there for a while. The vast majority of these substances are probably man-made. There are thousands of them. They were created for domestic use, medical use, industrial use, agricultural use. And there are probably more than there are thousands of them. But there are also some naturally occurring emerging contaminants. And an example of that would be cyanotoxins, which are generated by blue-green algae when there are algae blooms. And this is considered an emerging contaminant because there didn't used to be so many algae blooms because there weren't such concentrations of populations near lakes or nutrients going into lakes which fed algae blooms. Another naturally occurring emerging contaminant is manganese. And why is it new? Well, it's always been there. It's a trace element, but the science of neurodegenerative diseases has progressed to the point where it's recognized that this is a neurotoxin when you're exposed to sufficient. And so the word contaminant, what does that mean? Well, conventionally that applies to fresh water or to air, but not really to soil or to salt water. And so these contaminants, many of them are persistent. That's why we're able to detect them. Some of them are ephemeral, but their persistence is also part of the picture in that they are often, because they're man-made, they were engineered to be persistent so that they would have perhaps a long shelf life. Or if it's a medical agent, that it would last in your body for 2 days, so you would only have to take the drug every 2 days, etc. So how do they get into water? So there are 2 ways that these get into water largely. The terminology is there a point source or are there non-point sources? And point source means, is there an industry there? The classic example being Hoosick Falls in near Albany, where there was an industry that made plasticizers for years, and some of the residuals were put into the river and bioaccumulated there over the years and eventually got into the groundwater and were detected as PFOAs at Hoosick Falls, very poisonous, very bad, about 15 years ago. So those are point sources. Our local point source, and we do have one for the Susquehanna, is our wastewater treatment plant. There are no point sources on Otsego Lake, but there are plenty of non-point sources. And so classically that would be runoff from roads, from drainage, drains, storm drains, runoff from agriculture or golf courses. But really, from the pharmaceutical point of view, it's leach fields from septic tanks around the lake. And so, you know, if you happen to have a home on the lake and you have a septic tank and it's absolutely up to date, state-of-the-art septic tank, it can't handle any of these emerging contaminants. It wasn't designed to do that. It's designed to handle nutrients that shouldn't get out. And it's designed to handle certain types of biological pathogens like E. coli. But these molecules leach right through the walls of septic tanks. They end up out in the leach field and they end up in the groundwater. So how did my interest arise in this? Well, in the 1990s, when I was a young internist, I started seeing patients with diabetes who didn't seem to have risk factors for that. This would be adult onset, not juvenile onset diabetes. And the classic risk factors are obesity and family history. And right around the same time, I became aware of the concept of endocrine disruption. That concept was put on the map by one Theo Coburn, who was a graduate student in toxicology, and her dissertation topic was assigned that she was to go to this place in upstate New York called Love Canal and figure out why there were these monsters in Love Canal, like salamanders with 5 heads and things like that. And when she went there, she found this soup of industrial waste, and she investigated the mechanisms which occurred during fetal development and were due to bizarre disruptions of endocrine systems during fetal development. So she coined the term endocrine disruption, and ever since then, there has been a robust and evolving literature based on epidemiology, animal models, and a lot of investigation into associations between the emerging contaminants and other epidemics, such as, for instance, the epidemic of autism or the epidemic of behavioral disturbances and infertility. Now, please note that I'm talking about, I use the term association advisedly, because in the world of science, of human and ecological science, it's almost impossible to establish cause and effect in human medicine unless you're willing to subject a population of people prospectively to a toxin and have another control group who's exactly the same and they didn't get exposed to the toxin. And so all you can really establish is an association. And to sort of clarify how important it is to recognize this caveat, I would like to point out that no one has ever proven that cigarettes cause lung cancer. What's happened is that the body of evidence, indirect evidence, from 1,000 different sources all pointed to this. And eventually the parties that were resisting this association said, okay, enough is enough. So I was aware of emerging contaminants. And after I retired, I thought of an interesting project. Did we have these in our beautiful lake? I had been reading about some isolated lakes in Minnesota that did not have point sources, but had feminized fish. And a feminized fish is a male fish that lays eggs. So I started looking into how you test to see if there are emerging contaminants on my own. And I learned that there are 2 really good markers for human presence in water, and they are sorbitol and caffeine. I thought, oh, okay, we'll just look to see if there's sorbitol and caffeine in the water. But it turns out it's very hard to find, you can't test water for just one of these things. You have to do panels, huge, big panels, and they're very expensive. Sorbitol and caffeine are embedded in these panels. And after some searching, I finally found some folks at the USGS who provided me and recommended 2 panels. One of them was a panel of over 100 pharmaceuticals and personal care products. And the other one was a panel called the pesticide panel, which was actually pesticides, herbicides, and fungicides. And I want to make an upfront statement about that panel. Glyphosate, which is the active ingredient in Roundup, was not on that panel. And when I inquired about that, I was told that it was because it was not amenable to mass testing with these other substances. I'm not enough as a scientist to understand that. So anyway, in the summer of 2018, with funding from the Biological Field Station, and certainly they helped to collect the specimens, as with the USGS as well, multiple samples were taken from the lake. And Martha, would you please show us table 1, which is, I'm going to show you what these samples showed. Okay, thank you. Great. So this table is entitled Emerging Contaminants in Otsego Lake, the Drinking Water Treatment Plant, the Wastewater Treatment Plant, the Westlands, and the Susquehanna River. So if you look along the left-hand side of this table, you'll see how we track this. There were 2 tests of fresh water. First in Otsego Lake near Ferry Springs, which is the intake pipe for the drinking water of Cooperstown. The next site where we tested was after treatment at the drinking water treatment plant. And then we looked at the waste stream that was coming through the village. And so we collected a specimen just before the waste stream entered the wastewater treatment plant. We collected again after the wastewater treatment plant. And then probably you are aware that there is a small wetlands immediately south of, between the wastewater treatment plant and the Susquehanna River, there's a wetland. And we tested it after the waste stream had gone through the wetlands. And then finally, a sample was obtained at wading distance into the Susquehanna River. And basically what that means is that the waste stream was allowed to mingle and be dilute by whatever volume of water was coming down from the lake in the river. Okay. So you can see that all of the numbers here are, I've written in terms of micrograms per liter. Everything's translated into micrograms per liter. And you can see across the top of the table that there are 3 substances that were found in the lake: atrazine, metolachlor, and metformin. And atrazine is an agricultural herbicide. Metolachlor is another agricultural herbicide, which is often mixed with atrazine. Metformin is a very commonly used drug, which is very helpful for management of adult onset diabetes. Now you'll see that some of these boxes have dashes in them. And the reason for that is that we didn't have enough money to track the pesticide panel down through the village, through the treatment plants and into the river. We only had enough money to repeat the pharmaceutical panel. And it happened to be that atrazine was on the pharmaceutical panel, although I don't know why. So we were able to get more values on atrazine. So you can see that there were these amounts of atrazine, metolachlor, and metformin in the lake. By the time treatment had occurred at the drinking water treatment plant, there was less than a microgram per liter of both atrazine and metolachlor. And the abbreviation capital MCL stands for maximum contaminant level, which is a New York State safety level through which drinking water treatment plants the size of our village are supposed to make sure that probably a panel of about 150 substances are sought, and they're supposed to be less than that amount. There's nothing in the New York State law about checking for metformin in drinking water, or for any other pharmaceuticals for that matter. That's not true, excuse me. I'm not sure about the other pharmaceuticals. Anyway, I'll take that back. Anyway, you can see that the drinking water treatment plant did not find other pharmaceuticals in our drinking water, nor did they look for metformin, and I don't think they looked for other pharmaceuticals. And when you go back over to atrazine, you can see that it it tracked through the village at basically the same amounts. It didn't really change in the wastewater treatment plant. And actually it was a little higher concentration by the time it got in the river, because probably there was some drainage into the river beyond the lake. And when you look at the metformin panel, you can see that by the time we were tracking wastewater, there was a huge amount of metformin in the wastewater. And the wastewater treatment plant was able to remove some of it, but certainly not a lot. The wetlands removed quite a bit more, and dilution did bring it down somewhat. And in terms of pharmaceuticals, the village waste stream was packed with pharmaceuticals, and the wastewater treatment plant and the wetlands were not very effective at removing the pharmaceuticals. So the question is how to interpret this. Well, I think the good news is that the amounts in Otsego Lake of either pharmaceuticals or pesticides were very low. We'll talk later about whether that means anything or not. There are no lakes this size for comparison. So I don't really know how we stood in comparison to other lakes in New York State, certainly. And the other thing we concluded was that the wetlands were about 30% more effective at removing metformin and atrazine than the wastewater treatment plant. And this too is not very surprising. The wastewater treatment plant is not designed to remove any of these substances either. And the breakdown of metformin and atrazine probably occurred due to sunlight exposure and microbiological breakdown by microbes in the wetlands. The thing that you should know about atrazine and metformin is that they are ubiquitous, and especially metformin. I am told that it is found in every water sample that has ever been taken by the USGS in the Northeast. That's a problem. It has no break, it doesn't break down. It's a very persistent bioaccumulating agent. So please go to slide 2. Thank you, Martha. So I just wanted to go over some conventional nomenclature about orders of magnitude so that we can talk intelligently about this, the micrograms per liter concept. So you're probably all totally familiar with this, but just for review, 1 times 10 to the minus 6 is a microgram, and it's abbreviated 1 mcg or 1 mu, and there are 5 zeros. And then if you add 3 orders of magnitude smaller, you'll get a nanogram, which is an ng, and add 3 more orders of magnitude smaller and you'll get a picogram. And another way that you'll often see in the toxicological literature is how many parts per billion. And the term 1 microgram per liter, which I've translated everything to in this talk, is the equivalent of about 1 part per billion. So what is 1 part per billion? To make it as sensible for us is to imagine a drop of water in an Olympic swimming pool. Later in the talk, I'm going to be talking about things that are circulating in the human body in picogram amounts, 1 picogram per liter, which is 1 part per quadrillion, which is basically 1 drop of water in 60 Olympic swimming pools. So the thing to recognize about orders of magnitude is that almost all of the epidemiology and toxicology literature is based on the concept of micrograms per liter. But recent technological advances have made nanograms per liter readily available. And then finally, the thing that is most disturbing is that most hormones, neurotransmitters, and messenger molecules in vertebrates anyway, travel in picogram amounts. Okay, so So the good news is that the lake has only 3 contaminants and they're in very low levels. But the bad news is that the lake should contain no contaminants. And the river is definitely filled with stuff from our village, which our wastewater treatment plant, just like all the other wastewater treatment plants, is unable to remove. So why should we be concerned about this, even though the lake and the drinking water readily meet New York State standards as they are published, and also readily meet the EPA standards? So I'd like to look at this through the lens of endocrine disruption. There are a lot of ways to look at toxicology. You can think about whether things are carcinogens. You can think about whether things cause neurodegenerative diseases. I'm not going to talk about those today. I'm just going to talk about endocrine disruption. So that's the next talk, part of the talk. So what is the endocrine system? It's a group of tissues which release hormones. These travel through the circulation to act upon remote tissues where receptor sites receive instructions regarding appropriate actions, send back feedback loops, and there are complex cascades of crosstalk between various receptor sites using hormones as messengers. If you go to the Wikipedia and you ask how many hormones there are in human beings, they'll tell you there are 46 hormones. Most people think of hormones as just something that adolescents get that cause pimples. And unfortunately, the EPA also seems to think that in the sense that their endocrine disruption program only has 3 hormones in it, estrogens, androgens, and thyroid hormone. When you take into consideration that there are receptor sites for each of these 3 hormones on every organ in the human body, in other words, there are receptor sites for estrogen in your heart, your brain, your bone, your kidneys, your parathyroid gland, everywhere. If you imagine the permutations of what could go wrong with just these 3 hormones and every organ in your body, the permutations are huge. And if you consider that there are 46 hormones in there, the permutations are astronomical. So when we talk about the endocrine system, I think there are 2 important features of the endocrine system to bear in mind. One I mentioned already, which is that the concentrations of these hormones are in picogram amounts. And then the other concept is something called hormesis, Hormesis. And it is a concept describing how at different stages of development or at different durations of exposure or different doses, an exposure can have exactly the opposite effect on an endocrine system. So we're all, I think, familiar with the concept of hormesis, for example, in homeopathy, where you start taking a very tiny little bit of arsenic and it seems to make your skin look nicer. And it doesn't hurt you until you took a whole lot of it. So traditional toxicology gets in trouble with these 2 features of the endocrine system. In order to demonstrate why traditional toxicology gets in trouble, I would like to show you a couple of graphs. Figure 3, please. Now, these are handmade graphs, and the best I could do. And Martha tried very hard to make them more suitable, but here they are. So figure 3 shows what is called a traditional dose response curve. And dose response is, kind of a way of talking about the relationship between exposure and the result. So on the horizontal axis is the amount of exposure, also known as a dose, and on the vertical axis is the response. And you can see there's a rough relationship here. In fact, you can draw a red line, which is often done, showing that there's an association between these, between the amount of exposure and the response. And this curve is called a linear curve. It's monometric. In other words, it never changes direction. Now I'm going to give you an example in figure 4 of hormesis. And here the curve changes direction. And you have a few cases on high dose and you have a few cases on low dose, but you don't have any cases at all in the middle range. So this is a non-linear, non-monometric dose response curve. Next figure, please. So here's an example of a non-monometric dose response, or also we've talked about calling it hormesis. And there's a drug that is very commonly used called tamoxifen that's used for estrogen receptive breast cancers. And if you look at the graph, you'll see that what we're calling tumor activity starts at a certain level. And when you start tamoxifen, shortly after you start tamoxifen, there's a whole lot more tumor activity. In fact, there's a big flare-up of tumor activity. But after a while, it goes down and it goes way down, and it ends up stabilizing at a level significantly below the tumor activity that you had before you started tamoxifen. So this is an example of hormesis. So the next figure, figure 6, is I wanted to show you how the EPA and other toxicology institutions establish the maximum concentration level. So lab animals will be exposed to a certain toxin, or you'll have some epidemiological evidence of exposures, and you'll see a bunch of cases. And so you'll put it on a graph like this, and you'll see that, gosh, it all seems to cluster up there on the doses above a milligram per liter. So if you can establish something like this and you can draw a straight line through it, what they do is they extrapolate. And so they extrapolate by orders of magnitude as a fudge factor to make sure that, you know, we're not blowing it here. And then they go all the way back down to wherever it crosses the y-axis. In this case, it happens to correspond to a microgram per liter. And they call that the maximum concentration level. And that's the threshold below which, above which you're not supposed to see in the water. So the next figure, please, is going to show how the world of toxicology can fail to recognize an association because of these two features: the very low concentrations that the substances are circulating in, and the nonlinear curves. And you can see here's for instance, let's say that this is a very common health issue that is common in the population. Let's call it infertility. And they can see that, gosh, you know, when we measured this substance in the milligrams per liter range or the grams per liter range, there seems to be a cluster of cases. And we can draw a line through there, and we can see that there don't seem to be any if we extrapolate down. And so we're going to say this is where the MCL is. But because they haven't taken into consideration that that line might be curved, and also because they're unable to or haven't got the data about these lower dose exposures, they've missed a huge bunch of associations in the low dose exposure. I hope that makes sense. So that's how a paradigm of toxicology thinking is being disrupted, and how difficult it is to establish. Clearly, there should be none of these substances in any of our water. Paracelsus, the father of toxicology, said the following: "What is there that is not a poison? All things are poison. Nothing is without poison. Solely the dose determines that a thing is not poison." So he sort of understood about hormesis, but that's not how the toxicology community worked with his dictum. And the maximum concentration level is being called into question now because of this. And there are a number of other features in biological systems that make the MCL concept antiquated and sort of speak to a more complex picture than just the dose. For example, we are now much more aware that there are vulnerable windows that may open and shut during development, during the life cycle, fetal development, old age. And these vulnerable windows may create greater susceptibility to alteration of an endocrine system. We also know now about transgenerational transmission of toxic exposures. This was first learned the hard way in the 1960s when diethylstilbestrol was given to women with threatened miscarriages, and female offspring of those pregnancies late in life, many years later, developed endometrial cancer. That's a transgenerational toxicity. And now we know that there are epigenetic issues that can go on beyond the third generation. And we need to really consider epigenetics in the world of toxicology. And finally, there is the issue of everything is available as a mixture. None of these substances come in isolation. So how to, let me just make sure I take, could you please go to figure table, the last table, thank you. So what I'm showing you demonstrates a level of ambiguity and complexity, which is typical of the world of science. And it's hard to interpret or to know how worried to be about any of this. But let's go back to the three substances that are in our lake, atrazine, metolachlor, and metformin. The people or the agencies that have developed guidelines, there is a group called the Environmental Working Group, and the abbreviation EPG is wrong. It's EWG, of course. And they, I think, are careful and thoughtful, and you can go to their website about any information you want in the world of toxicology. I think they're quite credible. And they've established a threshold of that's lower than New York State's threshold of 1 microgram. Their threshold would be 0.1 micrograms. They've not looked at metformin or metolachlor to establish thresholds. The New York State drinking water standards are less than a microgram. The EPA's standard is 3 micrograms. Now, I would like to just take a look at what you'll see as lab evidence of Piscine feminization. That means fish, male fish that are getting ready to lay eggs. And if you have some male fish swimming in a bath where the concentration of atrazine is 2.5 micrograms per liter, you'll see this happen. There's very little literature about metformin because it's a relatively new contaminant, but it doesn't take much metformin to feminize fish. And it doesn't take much to feminize salamanders either. I think we will be learning a lot more about metformin as time goes by.
Antoinette,
yeah.
I'm just interrupting because although we have other questions, you used the word epigenetics just now, I think, with table 3. Can you explain that briefly?
Yeah. So the concept of epigenetics is a recognition that there are molecules that are clinging to and surrounding the DNA helix that are transmitted, but that are affected by the environment in ways that the DNA during mitosis and reproduction, the DNA is not affected, but these other substances are definitely environmentally affected. And so that has given rise to a field of epigenetics in which it turns out that that nature and nurture, that old argument, that it could be that the giraffe's neck got longer because he was stretching it to reach the leaves at the top of the tree. It's not just the DNA. So it says a lot more about environmental effects on fetal development than just passage of DNA. It's a complicated issue, and it's very hard to read about it, and it's highly controversial, but it's almost certainly there's a real phenomenon. It was first recognized in a third generation offspring of people who survived a Dutch famine during World War II, who were pregnant during the famine. Their children were obese. And well, you could explain that by saying that they got their endocrine system in fetal development was in disarray because of the mother's starvation, so that they were more thrifty with calories. But their children are obese also. And so that is being looked at as probably an epigenetic phenomenon. But the only way you could really demonstrate that is to look at the next generation of children, which is why I mentioned 4 generations. I want to go back to, hold on. Oh yeah, why it's so hard to ever get anything to happen in the world of science, why people disbelieve science, because it's precisely because of the difficulty of establishing these things. And it's very much a 2 steps forward, 1 step backward phenomenon. And that's why somebody could actually be a climate change denier. I can think so much I laugh a lot about how the food pyramid and the advice that we should never eat eggs because they had high cholesterol in them. And it was well known when that advice became institutionalized that dietary cholesterol had nothing to do with the cholesterol that circulates in your body or the cholesterol that they would find in those plaques in your heart. It took 40 years really for that dietary cholesterol thing to become well established. So institutional recommendations often lag way behind science, and there's always pushback. So what to do? I just want to say that the Biological Field Station did purchase a reader to do further testing. Their immunoassay instrument is geared to test one substance 100 times rather than 100 substances one time. And it came with 2 free samples. One they chose glyphosate and atrazine. And last summer they took samples in many streams and the lake, and the data is not in. But if you are interested in this, you can, if we are able to do these things this summer, join the citizen science through the OCCA or Otsego County Conservation Association to collect samples for the Biological Field Station. And you can contribute towards the reagents if you wish. They're very pricey. And in terms of political activism, I should say that atrazine is also a known carcinogen, and it's been banned in Europe for 10 years. There's been legislation in the New York State legislature that is stuck in committee now for a long time that might actually get passed this year to ban atrazine in New York State. although glyphosate has become more widely used than atrazine, atrazine is still being used. And so the issues with glyphosate are complicated. It doesn't bioaccumulate in the same ways that atrazine do, and the science behind its toxicity is also in its infancy. It's probably the agent that it's used with that causes toxicities. So I can't really say what we can hope for with glyphosate, except that I know when Germany tried to ban glyphosate, there was a huge parade of angry farmers on tractors. And I just for the devil's advocate approach, why shouldn't we ban metformin? If I were a farmer and I didn't need to use metformin because I didn't have diabetes, I would say, hey, you guys, this thing is just as ubiquitous, and why don't we ban that? And really, when you think about it, metformin crosses the placenta, is ubiquitous, and it probably does have some effect on fetal development of the crosstalk between insulin creation of insulin and sensitivity to insulin in the tissues that are sensitive to insulin. Who knows? Maybe it'll just, we just don't know. So I would like to recommend that if you have people in your life who are of reproductive age, both male and female, that they use charcoal filters on their water. And charcoal filters do filter out most of these substances. And go to the environmental working group if you want to read about them. And finally, I think it's possible that the wetlands could be expanded or improved in some way to be more effective to protect the Susquehanna. I have no idea about that though. So that's everything I had to say. There is a bibliography to this talk. Martha, if you could just show that next. And it will be available to you on the YouTube, which will also be available in the the YouTube on the FOVL website. So could you go back then to full screen, and I'd be happy to take any questions if there are any that I can answer.
Antoinette, I want you to know that I paid a little extra money to have a smoke screen on my Zoom so that you don't see the smoke rising from my brain. But I think it's your gifted intelligence that took a very complex topic into a very comprehensible way of transmitting a very important message. So thank you very, very much. So I've got some questions, but I wanted to say initially that Antoinette, though a scientist in her practice of medicine, does not profess to be an expert on the science of emerging contaminants in our lake, but she is connected. She's well connected to those who are experts, and she invites your questions, if some remain, or some that she may not be able to answer, to her email. Her email is Antoinette, spelled like the 18th century French queen, Kuzminski. I don't have a historic reference for that, but it's one great big long Antoinette Kuzminski @gmail.com, and she will pursue the answers and get back to you. So let me present some of the marvelous questions that have been posed. This is a compelling question from a listener who asks, if even state-of-the-art septic systems can't handle modern emerging contaminants, well, what risk does one take swimming in lakes and ponds near or downstream of septic fields? And what about stocking ponds with fish for consumption?
Well, I would suggest you not swallow the water. No, I don't think there's a risk right now to human health swimming in Otsego Lake. Not that we're able to identify. I certainly would not tell you not to swim in the lake. I think the lake is as safe as any swimming water anywhere. But I think the presence of these substances is interesting. What happens next? Well, I could say that something I didn't mention was that I understand that the pharmaceutical industry is trying to rethink many of these pharmaceuticals so that they do break down faster. And so the metformin that's out there now, which will probably never go away, may be replaced by a better version of metformin in the future. When I first heard about metformin being in the lake, I thought that's great, because everybody's going to get diabetes, and it's the treatment of choice to prevent progression to insulin requirement. But then when I started thinking about its effect on the next generation, the little fetuses that are in there, so I still swim in the lake, and I would definitely put a charcoal filter on village water. I have not, I don't really know about, the groundwater that's around all of us. It's in groundwater though, for sure.
And here's a follow-up related question. Is there any work being done on improving septic systems, I imagine, so that these contaminants can be screened out?
I don't know about improving septic tanks per se, because I've only read about improving wastewater treatment plants, and there are many, many attempts to improve their method to remove emerging contaminants. Most of them are quite expensive, obviously. They involve things like reverse osmosis, which is kind of like those machines that make maple syrup out of maple sap. They push the molecule through a membrane. Some of them involve types of irradiation that aren't done in routine wastewater treatment plants. But I have not seen any literature that addresses individual septic tank, what to do about individual septic tanks. I think that, there are places along the lake that have not been able to even put in a leach field, that, the geography is such that they can't control anything. And so they have to have something that is, a tank that's removed, right? I think that is one of the methodologies, is that nothing from your house gets in the lake, no matter what.
Antoinette, one of our listeners is familiar with Dr. Colborn's research and writes that this research showed that very small amounts of certain toxins may cause endocrine disruption. Could the contaminants in the lake cause certain disruptions in our population, our local population, I imagine?
I think I have not read Theo Colburn's work, and I don't know the concentrations of the materials that she was looking at, but I suspect that they were much, much higher than what we're seeing in the lake. I know, I don't just suspect it, I know it, and they were multiple also. And the three contaminants that we're seeing in the lake water, atrazine just shouldn't be there, period. It's a known carcinogen. You don't have to hypothesize endocrine disruption, right? So on the other hand, chlorine is a known carcinogen also, and we use it in the swimming pool at the gym all the time. I don't know the concentration, but I think our lake is not, I don't think that humans are spending that much time in the lake the way fish are, but I don't know. I don't know the answer to that.
Well, I think one of the other elements of emerging, the term emerging contaminants is that risk is not yet fully understood. And so stay tuned, right?
Right.
Can you tell us what is understood about why wetlands are so effective at removing contaminants?
I don't think they were highly effective. They were more effective than the wastewater treatment plant. I think, I had several great articles about that, and I'm not sure if they're in the bibliography. I know that it has a lot to do with dwell time. So, and the depth of the wetlands. So if the wetland is quite deep, you don't get as much benefit. So you need certain types of plant life at a certain very shallow, and you need a certain population of organisms that are eating and breaking down things, and you need sunlight there. And it's not surprising that is going to break down things more than the wastewater treatment plant is, but it's not a miracle either. There was still plenty of stuff coming out the other end. But, it is so much more sensible to have a great big wetland, and it's so much cheaper than trying to, have a reverse osmosis of all the wastewater that goes through. I was really.
For the past 10 months, our local population, in fact, our world, has been using a whole lot of disinfectants. And I'm wondering if you came across anything about disinfecting byproducts related to emerging contaminants.
Yeah, I'm sure that there's tons of stuff about it, but it wasn't in the panels that I used. So I don't know much about it. But there's a lot of literature about those little micro beads that people use to, abrade the skin off their faces, and those are forever.
What would you say? I know your data are limited by what you tested for, but what's better for human beings? Contaminants from an industrial environment or contaminants from an agricultural environment?
I would say agricultural for sure.
Better for humans.
Better, yeah, because they're not as numerous. And also they are much less likely to be simply evacuated into water. They are likely to go through a whole bunch of breakdown out in the field. That happens to glyphosate out in the field. So that's where the literature about glyphosate's half-life, Roundup, is based on how rapidly it's broken down in the soil. Honestly, we know nothing about how rapidly it's broken down in water, and we know it seems like it's forever in Cheerios because it's detectable in the wheat products that made Cheerios before, Nabisco or whoever makes Cheerios said they would never, they were going to stop using those products. What was the question?
About the industrial versus.
I think that, exposure to the real world outside is probably safer. Yeah.
All right, well, we're coming close. I have one final question. You mentioned one action we should take to add a charcoal filter to drinking water, not just for consumers of village water, but outside the village have a well, and so there may be contaminants there that you just haven't found. So in addition to that, how would you like us to be different, having heard your wise words these past several minutes? What else would you like us to do? What else should we or could we do? So that we don't end up with 5 heads like a salamander.
Well, we're not going to do that. We're exercising the precautionary principle. We're trying to understand. Well, I think all we can do is contribute to agencies like Environmental Working Group and the Biological Field Station, which has a great interest in this. I think we cannot harass the farming community about their use of pesticides. We have to understand what they're using those things the same way we're using metformin.
Mm-hmm.
And so I think we have to sort of see the big picture and get some perspective here and hope for a greener engineering. Definitely atrazine, if that law could be passed, that would be good. You could write to your assemblyman about that. But I think they just have some perspective.
Okay, I don't want to disappoint our listeners, so I want to just add on a question or two. You mentioned charcoal water filters for people of reproductive age. What about for people with children and the effect on
Oh, yeah. Oh, sure. Yeah, actually, of course.
Yeah, okay. This individual also thanks you for a great talk.
Mm.
And then I guess we'll call this the final one, given our time. I think you did answer it. It asks about specific entities, golf courses, homes along the lake that might be contributing to contaminants. I think your answer was that the best of our septic systems, the state of the art, still are not 100% effective. Would you comment additionally?
Well, I think that the septic systems around the lake are probably more likely to cause a problem in the lake than septic systems distant from the lake. And I think there is breakdown that occurs in leach fields. I'm not sure I understand the question now.
The questioner was asking about specific entities that might be contributing to contaminants.
Well, storm drains, road runoff, the streams that enter the lake they're running through populations, areas that are populated. Mm-hmm. And I mean, it's not like people are throwing metformin tablets into those streams. They're not.
Right. And of course, our public education of late has been to not throw extra medicine
Right.
into the toilet, which had been seen as safe at one point, but now we have public systems that will collect unused medicines and expired medicines rather than us putting them anywhere.
Oh, for sure. But we need to be cognizant that all of the metformin that's in the lake went through somebody's mouth, yes, intestines, poop, septic tank. Yeah.
Well, on that very lofty end.
They did not just flush it down the toilet. No.
We'll pull Leanne back in for her final remarks. Tanette, thank you so much.
That's so fun.
Your listeners are very appreciative.
Yes, thank you, Tanette, Martha, and Maureen for an excellent program today. I'm just going to share my screen to give you a quick reminder about what's coming up later this month and next month. So give me a second. Okay, so starting on Wednesday, January 27, Looking in the Mirror, Cooperstown Reflects on Racism, returns with Racism and Arts and Monuments, featuring Town of Otsego historian Tom Heitz, Fenimore Art Museum curator Eva Fognell, professor and director of the Cooperstown Graduate Program Gretchen Soren, and artistic and general director of the Glimmerglass Festival Francesca Zambello. On Wednesday, February 10, Looking in the Mirror series continues with Racism in Law Enforcement, featuring Otsego County Sheriff Richard Devlin, SUNY Oneonta EOP Counselor Bryce Wooden, Cooperstown Mayor Ellen Tillapaw, Rockefeller Institute of Government Director of Policy and Practice Joseph Popkin, and Cooperstown Police Chief Frank Cavalieri, And on February 21, the Sunday Speaker Series will present a panel discussion with local artists about the legacy of women artists in Otsego County. And then in March, Sunday Speaker Series will host Tim Johnson, CEO of Otsego Electric Cooperative, who will speak on the struggle to establish broadband for rural America. And the final Looking in the Mirror session will take place as well. The Sunday speaker programs, they're scheduled for 3 p.m. on Sundays. They are via Zoom. And then the Looking in the Mirror sessions, they start at 7 p.m. Also on Zoom. Both program series are free and open to the public. And participants may register for the programs by going online at FOVL.eventbrite.com. And if you have any questions or comments, please email FOVLfriends22main@gmail.com. And I will stop my share. And thank you all for joining us. And we hope to see you on February 10th. Goodbye, everybody.